Good day to all my chemistry connivers out there. We're going to continue on with the second part of our chemical nomenclature video series, which in this video we're going to be doing the reverse of what we were doing. We're going to go from a chemical name to the chemical formula. So this one's a little bit simpler. We're going to be deconstructing the flowchart that you saw in the last one and sort of working backwards and reverse engineering our chemical names. In order to select which rule to use to convert your name back into a formula, it's going to be all about the endings that you see. And the endings that you will see are "ide," "ite," "ate," "ick," and "us." So be on the lookout for one of these 5 endings. Also be on the lookout for any numeric prefixes: mono, di, tri, tetra, etc. So let's break into the different kinds of ways that you're going to use the flowchart sort of backwards. The first and the easiest one is if you do see the numeric prefixes: mono, di, tri, etc. If you've got those, it's easy, cake. Just use whatever those prefixes tell you for each element, the number that they would have. So mono, 1, di, 2, and you're going to get your formula there. There's one pitfall that I want to make sure that you guys avoid, and it's dichromate, dimercury, disulfide, and dihydrogen phosphate. Yes, these do have a numeric prefix, but that's just part of the name of a polyatomic ion. So if you have one of these, you're going to go down to bullet number 3, which we'll talk about in a second. If you see the ending "ide," you need to put your polyatomic ion sheet away. And that is because the "ide" ending indicates that you have a single non-metal element as your anion. So don't look on the polyatomic ion sheet. Look on the periodic table to find its charge and charge balance with whatever your cation is. Also note that in this direction, you're going to know the charge of both the cation and the anion. The anion, because it will either be a polyatomic ion or one of the nonmetals that you can identify, and the cation, because it will be S block or aluminum, or if it's not S block, it will have its charge indicated in Roman numerals. So you will know both of the charges to carry out your charge balance. So none of this stuff where you have to do some work like in the other direction to figure out what the charge of the cation is. There is one pitfall here for the "ide" ending, and it is that hydroxide, peroxide, disulfide, and azide, these do have the "ide" endings, but they are polyatomic ions that you should be aware of. So if you see one of these, skip down to bullet number 3. So let's talk about bullet number 3. And that is, if you see the "ite" or "ate" ending, you have a polyatomic ion. The only exceptions are these 4 that are mentioned here. So if you have "ite" or "ate" or one of these 4, you need to get out your polyatomic ion, find its charge, and charge balance with that of the cation. Remember to only put the polyatomic ion in parentheses if you have more than one. The Moodle assignment will definitely count you wrong if you use parentheses when you don't need to. Lastly, you will see one of our 3 rules for acids, and that's if you have an hydro-ick, ick, or us ending to it. So be careful with the "ick" ending, because you can have either this rule if you have the prefix hydro, or this rule if it's just "ick" without the prefix. If you have the hydro-ick, again, no polyatomic ions. You're going to be making your acid by adding hydrogens to just a single non-metal element, and you're going to be adding enough to charge balance it. So chlorine would require 1 hydrogen, sulfur would require 2 hydrogens. If you see an "ick" or an us ending, and again, the ic would be without the hydro, so just plain ic or us ending, you do have hydrogens added to a polyatomic ion, so yes to your polyatomic ion sheet here. And again, add enough hydrogens to balance out the charge. Let's look at a few examples. Okay, so on the first one, I gravitate towards tetra. So I have a numeric prefix, so I'm going to be using that first tip that I talked about. And I know that I'm going to be making this out of carbon and chlorine. Tetra tells me that I have 4 chlorines. And remember that mono is left off of the first element, so you would just have to assume here that we have 1 carbon, so CCl4, and that is it. That's it. That's why numeric prefixes are your friends, because they make those problems very easy. On the second one, I see the "ide" ending, so that tells me not to look at my polyatomic ion sheet. I'm not going to be looking at SO4 or SO3 or any of that. I'm going to be looking at just plain Jane sulfur. So this is a compound made out of calcium and sulfur, and calcium is in the S block, so I know that it's 2+, and sulfur, I look at its location on the periodic table and it's 2-. And so now I'm going to charge balance these. The least common multiple of 2 and 2 is 2. So I only need 1 of each of those to get a neutral formula. Done with that. Alright, threw this one in there. I see the "ide" ending, but I'm not going to go after oxygen here because I have to think, oh, hydroxide, that is a polyatomic ion. That's one of the handful of polyatomic ions that end in "ide." So I'm going to go check my polyatomic ion sheet, and hydroxide is OH-. Potassium is in the S block, and it's potassium +1. My least common multiple of +1 and -1 is 1, and so my formula here is KOH. Okay, barium perchlorate. On this one, I see the 8 ending, which tells me I definitely have a polyatomic ion. I search for perchlorate, and I find ClO4. And my polyatomic ion chart tells me it's -1. Barium is S block, and it's 2+. So to charge balance this, I'm going to need 2 of the -1s to balance out my +2. So I'm going to say barium. I'm going to have to put the perchlorate in parentheses because I need 2 of them. So that's the correct answer for that. Carbon 8, polyatomic ion. I search for it, CO3, 2-. Cobalt is D block, but in this case, you will always know the charge even if you have a D block, because this tells me that my cobalt is +4. So now I'm going to charge balance +4 and -2, and so the least common multiple of 2 and 4 is 4. So I need 1 +4, and I need 2 of the -2s. So again, my polyatomic ion in parentheses because I need more than 1 of them. Ic. So that tells me I want to have some kind of acid, and this is a hydro-ic. So I'm not going to go find fluorate off my polyatomic ion sheet. I'm going to be dealing with just fluorine, the anion. So, and it's -1. So that will require me to put 1 hydrogen on it. Arsenous acid. So that's telling me that this is a polyatomic ion that used to be ite. So arsenite. So I'm going to be adding hydrogens to arsenite, which is ASO3, and this has a 3 minus charge on it, so I'm going to need 3 hydrogens to balance it. And that covers that. We'll have to take a poll as to which direction you guys think is easier, formula to name or name to formula. Have a good evening, guys. Talk to you later.